Hi, in this video we'll prove that the projection of u onto v is equal to u dot v over the magnitude of v squared times v. First, let's draw the two vectors u and v. If these are our two vectors, the projection of u onto v would be this vector, which we'll call k. Let's let the angle between u and v be theta. We'll have to consider three cases: when theta is acute, when theta is obtuse, and when theta is equal to 90 degrees. We'll first look at the case where theta is acute. If we want to find the magnitude of k, we can use this relationship where cosine theta is equal to the magnitude of k over the magnitude of u. So the magnitude of k is equal to u cos theta. We also know that u dot v is equal to the magnitude of u times the magnitude of v cos theta. We see that there's cosine theta on both sides. You can substitute cosine theta is equal to u dot v over the magnitude of u times magnitude of v. So we have u times u dot v over magnitude of u times magnitude of v. This cancels out and you get u dot v over the magnitude of v. We also know that k hat is equal to the vector k over the magnitude of k. So the vector k is equal to the magnitude of k times the direction of k. We know that the magnitude of k is equal to u dot v over the magnitude of v. And we know that k is in the same direction as v, which means that k hat is equal to v hat. So you can replace this with v hat. And then you're left with u dot v over the magnitude of v times v over the magnitude of v. That's v hat. And that's the projection formula. In the second case, we'll look at when theta is greater than 90 and less than or equal to 180. The diagram will now look like this. This is v, this is u, and this thing is theta. And that's k. I made a mistake. Theta is this, and this is 180 minus theta. So here the magnitude of k would be equal to the magnitude of u cos of 180 minus theta. Notice that we don't use theta here because cos theta would be negative and magnitudes can't be negative. So this is equal to negative magnitude of u cos theta, which is equal to negative u dot v over the magnitude of v, shown here. Again, k is equal to the magnitude of k times k hat. The magnitude of k is equal to u dot v, negative u dot v over the magnitude of v. And here in this case, you see that k and v are in opposite directions, which means that k hat is equal to negative v hat. So you can replace this with negative v hat. The negatives cancel out, and you're left with u dot v over the magnitude of v times v hat, which is v over the magnitude of v, which is this equation here. Lastly, when the two vectors are perpendicular, the projection is nothing. Again, the projection, the scalar projection of k, or the magnitude of k, is equal to u dot v over the magnitude of v. That does not change. And k is equal to the magnitude of k, which is u dot v over the magnitude of v times k hat. But in this case, since this part is 0, we can write anything for here. I can write 200 v hat. I can write anything. That includes the fact that I can write v hat here. So if I can also write this, then you see that the formula holds for all three cases: when theta is acute, when theta is obtuse, and when theta is equal to 90 degrees. So it holds for all cases.